Hey there, mathematicians. Miss Johnson. Today we are going to be talking about conversion word problems. You've been doing conversion word problems probably since fourth grade. Um, it's anytime you have to change from one unit of measure to another unit of measure, like changing liters to kiloliters or quarts to gallons or ounces to pounds. You would always use your reference chart when you had to do that. So the seventh grade reference chart looks like this. You can see like it just has the different, like 1 kilometer is 1,000 meters, a meter is 100 centimeters, right? So it has just the different equivalencies. That's what I was trying to say. The different equivalencies that different things can measure. The relationships are always proportional. They're always proportional because they're always the same. It's always 100 centimeters in a meter. Always. Like that doesn't change. So because of that, the conversion relationships are proportional. Okay, and if they're proportional, that means we can set up a proportion to solve it. And that can really help us because sometimes, especially when it's conversions that we don't really know and we're not familiar with, it makes it easier because the proportion basically tells us what to do. Okay, so this year, your conversion questions they're actually not on the reference chart. You're going to be converting between measurement systems. So you're going to be going from metric to standard and standard to metric. Okay, so they're going to have to give you the conversion in the problem. Okay, so let's go ahead and look at our first question. Okay, so before we look at that question though, go ahead and just jot some notes down here. It doesn't have to be a lot. Just jot some notes from the top part where we talked about. It doesn't have to be a lot of notes, but just a little bit. Okay. All right, let's go ahead and solve some questions. So our first question says, during 1 week, teachers drank 12.6 gallons of water from the water machine in the teacher's lounge. There are approximately 3.8 liters in 1 gallon. Which measurement is the closest to the number of liters of water the teachers drank? Okay, so we want the liters that the teachers drank. So what does it tell us about what the teachers drank? It says the teachers drank 12.6 gallons, but they asked us for liters. So they also told us that 3.8 liters is in 1 gallon. So we set up our ratio. Remember, we always start with our word ratio. We're going to do liters to gallons. So 3.8 liters is with 1 gallon, and that equals the 12.6 gallons is how much they drank. So our 12.6 will go at the bottom. Okay, and from this point, you can decide whether you want to cross multiply or you want to use the scale factor or constant proportionality to answer. So I'm looking right here and I'm saying, look at that. 1 times 12.6 is going to give me 12.6. So whatever I do to the bottom, I have to do to the top. So 12.6 times 3.8. Add it up. Don't forget to move your decimal. 1, 2, 1, 2. So 47 and 88 hundredths, which would be answer choice B. Now, if you had decided to cross multiply, the great thing about the proportions is that it really does take the thinking out of what you have to do. Like it makes it to where you can't really mess up, especially if you write your word ratio. You can't really put it in the wrong place. Okay, so let me do this, right? That's going to give us x, 1x, which is just x, equals 3.8 times 12.6, right? So it's telling us we have to multiply. So if we ever get confused about whether we have to multiply or divide, that proportion, when we set it up, it will tell us what to do. So that's why I love proportions so much. It just helps when, sometimes we just read it and we just don't know what to do, and it just helps us figure it out. All right, so number 2. Corbin is packing boxes that have a weight limit of 10 kilograms each. How many boxes does he need to pack 110 pounds? Okay, so what do we notice? This is 10 kilograms, but he knows he has 110 pounds. So it also tells us that 1 pound is 45 hundredths kilograms. Okay, so I'm going to read it again. All right, so Corbin is packing boxes that have a weight limit of 10 kilograms each. Okay, so in the box, he can only put 10 kilograms. How many boxes does he need to pack 10 pounds? Okay, well, I'm going to have to change the pounds, the pounds to kilograms before I can deal with this 10 kilograms each thing. Okay, I got to figure out how many kilograms he has altogether first. Okay, so my relationship that I'm going to be comparing is pounds to kilograms. So always write your word ratio first. So 1 pound is 45 hundredths kilograms. And then he has 110 pounds that he has to work with. So the 110 goes with the pounds, and I don't know how many kilograms that is. Okay, so if we cross multiply, right, x, 1x, or just x, is going to equal 45 hundredths times 110. Okay, so go ahead and multiply that. You don't have to watch me do it. You can go ahead and multiply that. You should race me and see if you can beat me. See if you can get done first. Don't forget to move your decimal over. So that would be 49 and 5/10. X is kilograms. So he's got 49.5 kilograms. All right, so he's packing boxes with a weight limit of 10 kilograms each. How many boxes does he need? So they're not asking us for the kilograms, they're asking us how many boxes. So every box takes 10, so I need to take the 49 and 5/10 and break it up into groups of 10. Bring my decimal up. So 4.95 boxes. Can he go to the store and buy 0.95 box? No, so that means he's going to have to buy how many boxes? That's right, 5. He'll have to buy 5 boxes. Okay, so you kind of get the idea, right? So you set up the proportion by what's being compared in the problem. Like number 1, it only had 1 step, but number 2 had 2 steps. So sometimes there's going to be more than 1 step that we have to do. All right, so you kind of get the idea. Okay, so I want you to read number 3. Try to figure it out. Set up the proportion that you think it's going to be. Try to figure it out, then unpause the video and watch to see what I do. Okay, so he drove a total of 10 kilometers from his house to the movie theater and back. So that's movie theater and back. Approximately how many miles is it between Jay-Z's house and the movie theater? Okay, so if this is his house and this is the movies, it says the odometer was there and back was 10 miles. So just one way, it's really messy. So just one way would be 5 miles. Okay, so when we figure this out, we know it's going to have to be 5 miles. All right, so we're doing miles to kilometers. Oops, I didn't label this right. This should not be miles. This should be kilometers. Sorry about that. What happens when you go back and reread the question? You get clarification. All right, so miles over kilometers. And 1 mile is 1 61/100 kilometers, or kilometers, however you say it. And I'm not looking at 10, I'm just looking at 5. right? Because this is a total there and back, and we only want between the house and the movie theater. So that's just 5. And it's kilometers. So it goes at the bottom with the kilometers. Okay, so we're going to cross multiply. Right, so we're going to say 5 times 1 equals 1 and 61/100 times x. So this will be 5 equals, and then to figure out what x is, we're going to have to divide. So we do neato, 5 goes inside. We have to move our decimal over to make this a whole. So 1, 2, 1, 2, zeros go here. All right, so 161 cannot go into 5. 161 cannot go into 50. 161 should be able to go into 500. Not 5 times for sure, probably not 4 times. In fact, if I look over here, my answer choices have a 3, a 6, a 1, and an 8. I know it's not going 1 time, so I know that's not the answer. So I have 3 other choices. I have a 3, 6, or 8. Well, it's going to go 3, right? Because we know that 5 would be the most that could go in 500, but that's too big, so it's got to be less than 5. So I love it when we have answer choices. So it's 18. And now if I bring down the 0, 161 goes in 170 just 1 time. Where is my decimal going to be at? It'll be right here. So 3 and 1/10. And I don't need to keep going, even though when I bring this down, it's going to, have, like I could keep going, but I don't have to keep going because this is enough for me to get my answer. So it's approximately 3 miles from his house to the movie theater. Okay? All right, so read number 4, try it by yourself, and then unpause the video and see what I do. All right, so his dog is 2 feet 5 inches. There's 12 inches as a foot and 2.54 centimeters in an inch. How tall is Ethan's dog in centimeters? Okay, so they must give me this 12 inches as a foot for a reason, right? So we see it's 2 feet and 5 inches. So, and I know that 1 inch is 2.54 centimeters. So that means I need to change all of this to inches. Well, there's 12 inches in a foot. So 12 inches in the first foot and 12 inches in the second foot. So 12 times 2 will give me 24 inches. And then 24 inches plus 5 inches will be, so the dog is 29 inches tall. Okay? Now I'm going to set up my proportion, centimeters to inches. So 2.54 centimeters in 1 inch. And then 29 inches. And x. All right? So cross multiply. Okay. Move our decimal. So x is 73 and 66/100 centimeters. And go ahead and put that in your griddable. This one's pretty easy because just go straight. All right, so same thing. Pause the video, try number 5 by yourself, and then check it. Okay, so what's different about this one is that we have that 1/8 as a decimal, so we need to, as a fraction, so we need to change it to a decimal. And when you do that, it's going to be 0.125. So this will be equal to 2 and 125 thousandths. So when we cross multiply, that will be x equals 2 and 125 thousandths times 25 and 4/10. Okay, so this is going to be a lot of multiplying. So 25 times 2 is 50, right? So I know my answer's got to be around 50, so it's either going to be A or B, right? Oh, this should have been in millimeters. Not. But it's too close. That 10 is too close for me to say it's 54. So it's just because it's just 10 away. So it's too close for me just to use that estimate of 25 times 2. So we are going to have to multiply it out. Whoops. Okay, I am not focused. I'm sorry, guys. Okay, let me restart. So 25, 2, 10, 11, 12, carry my 1, 5, 6, 10. Okay, don't forget that when you have your third row multiplication that you need 2 zeros. Okay, 2 zeros there, one for the 4 and one for the 5. And then you start putting your answer underneath the 2 because that's what you're multiplying by. So that's 10, 4, 5, 2, 4, 11 and 8 is 19. Okay, so now we move our decimal. So we have 3 here, 1, 2, 3, and then 1 here, so that's 4. So 1, 2, 3, 4. So the number of millimeters is 53 and 975 thousandths, which would be about 54. Ooh, it's a lot of multiplying there. Not hard, just a lot of it, right? All right, number 6. Again, pause the video. Try to do it by yourself first. All right, it says a can of soda has 12 fluid ounces. 1 fluid ounce, there's that many milliliters. Oh, look at that. How many liters? But that's milliliters. Would it be in a 24-pack can? Okay, so it doesn't tell us, but on our chart, it would tell us that there's 1,000 milliliters in 1 liter. Okay, so we would have to know that. All right, so we're going to have to do the liters at the end because we know the relationship to milliliters. So ounces to milliliters. I guess we could change the milliliters to liters. We'll just leave it like that for now. So 1 fluid ounce is 29 and 57 hundredths. And then I have 12 fluid ounces, and I don't know, do I have 12 fluid ounces, or do I really have, because they want to know about the 24-pack. I wonder if I should go ahead and multiply 24 times 12. Because really, that's how many fluid ounces I have. But I could just multiply by 24 at the end. After, because this will give me the number of milliliters. I think I'm going to do that. So I'm going to figure out how many milliliters in 1 can. And then I'm going to multiply by 24 to figure out how many milliliters will be in 24 cans. Yeah, that's what I'm going to do. Okay, so 1x equals 29 and 57/100 times 12. Easy to multiply by 1 and 2. I'm thankful for that. Move it, move it, move it, move it. So 354.84 milliliters. Oh, look, there's that right there. But I know that's not right because I have to do 24. And this is milliliters, not liters. I think I want to go ahead and change it to liters. So it's 1,000 milliliters in a liter. So I have to divide this by 1,000. Okay. So when I divide that by 1,000, it's going to move the decimal point 3 places to the left. 1, 2, 3. Think about when we learned about when we move the decimal point, when we're multiplying dividing by 100. It's the same thing. We're just multiplying by 1,000. So we have to move it 3 times instead of just 2 times. So to the left. So it's going to be liters in 1 soda. So we have to take that and multiply it by 24. Oh, that's a lot. We're going to have to go scooch over a little bit. Do you think that I need to use all of those numbers? Or do you think that I could shorten it a little bit? What do you think? I bet we could shorten it because when we look at our answer choices, we have 8 liters, 354 liters, 288, and then 8,000. So like those numbers are super far apart. So I'm going to make this shorter. I'm not going to do it by all of those numbers. I'm going to do 354 times 24. That will be plenty enough for me to be able to tell what the answer is. You know, being exact is not always necessary. So when you look at your answer choices, that can help you problem solve through, okay, well, how many, how can I make my math a little bit easier, right? So, whoops, sorry about that. All right, so we're going to move 1, 2, 3. So 1, 2, 3. So it'd be 8 and 496 thousandths. And now remember, I rounded, right? Okay, I didn't use all the numbers. So this is the only one that's even close. All the other ones are far away. So our answer is going to be D. Ooh, that was a lot. But we did it. Good job, guys. All right. Not hard. It was just multiplying and dividing. It was just a lot of it. And we don't want to get lazy and get a question wrong because we're just lazy, right? All right, number 7. Davis built a shelf that holds a maximum of 30 kilograms. If Davis has a set of books that weighs a half a pound, oh, almost forgot that word right there, each weigh a half a pound, how many books can Davis put on the shelf? And it tells us that 1 kilogram is 2 2/10 pounds. Okay. So this is going to be more than one step, right? So the books are half a pound, and we want to know how many books are going to fit. Well, it says 30 kilograms, so that means I need to change the kilograms to pounds. Well, I could change the pounds to kilograms. I think I'm going to change the kilograms to pounds. So pounds to kilograms. So 2.2 pounds is 1 kilogram, and then I have 30 kilograms. I don't know how many pounds that is. So cross multiply. So x equals 30 times 2.2. Don't forget to move your decimal at the end. Okay, so that 66 pounds can fit on the bookcase. So each book weighs a half a pound, so that means we need to take the 66 and we need to see how many half pounds will fit, so we need to divide it by a half. So we're dividing it by a half, not dividing it by 2, we're dividing it by a half, right? So I'm just going to go ahead and put that over 1, and then we're going to do keep, change, flip, or we're going to multiply by the reciprocal. That's right, multiply by the reciprocal. We just flip the numerator and denominator. So we're just going to do 66 times 2, 132 over 1, which is 132 books. 132 books. You know, if you had gotten here to your half pound and you were like, I don't know what to do next. Well, any multiplication or division question can be solved using a proportion. Okay, so we could compare the books to the pounds. We know one book is a half a pound, and I know that we have 66 pounds, and we don't know how many books that is, right? So we cross multiply, 1/2 x equals 66 times 1, which is 66, right? And then what's the opposite of multiplying by 1/2? So divide by 1/2. So you would divide by 1/2, and it would end up being what we had here, right? That would match. So if you ever are looking at a question and you're like, man, I just don't know if I multiply or divide for this question. And a lot of times, well, sometimes when fractions and decimals are thrown into a situation, like it confuses us and we're not sure what to do. So anytime you have a multiplication or division situation, you just have to figure out what you're comparing, and then when you figure out what you're comparing, you can set up a proportion, and then your proportion will tell you what to do. It'll tell you if you multiply or divide. Okay, so just keep that in mind. Proportions are great tools to help you problem solve 3 things. Okay? All right, so good job on that. Go ahead and practice with your next questions on Canvas, and